Good morning, class. We are looking at more of sinusoidal functions, phase shift, and curve fitting. So we are adding, in essence, to what we have learned before. We're going to look at graph of sinusoidal functions of the form that they require phase shift and build sinusoidal models from data. And I'm going to remind you of what we learned about sinusoidal functions. Basically, one easy way is to come up with the period and cut it into 4 equal pieces. 1, 2, 3, 4 arcs. The same thing here, 1, 2, 3, 4 arcs. That's how we graph a basic sine or cosine function. And then if there is a change, we pay attention to the period, amplitude, and other things. As far as secant, cosecant, tangent, and cotangent, the general idea is here as to what we do to graph them. So we are going to move on to new stuff. We just covered those functions. So when you have a sinusoidal function of the form y equals a sine parentheses omega x minus phi, where we are assuming a, omega, and phi are positive. And by the way, in some texts, I'm going to emphasize this is a sine bx plus c and so forth. So they may use a, b, c, d. It means the same thing. So phase shift, assuming this is positive, it has moved to the right, and the period is 2 pi divided by omega. So I want to pay attention to all of those. Therefore, we can write the general formula as y equal a sine omega x minus phi plus beta. It's important to bring the omega out. When you do that, then 2 pi divided by omega is your period. And this is your phase shift. Assuming everything is positive, this much to the right. And b up and down depending upon the value of b being positive or negative. So when you have those, the amplitude is the absolute value of a, the period is 2 pi over omega, and the phase shift is phi over omega. And if phi is positive, ps, by the way, short for phase shift. All right. So the steps are very similar to what we have seen if we have a general case of a sinusoidal function. And the amplitude is obvious, the absolute value of it. First, we find the t 2 pi over omega. We also find the phase shift phi over omega. And then we move this to the right and we cut it into 4 pieces. So determine the starting point of one cycle of the graph, which is phi over omega. Determine the ending point of one cycle, which is phi over omega plus 2 pi over omega. And this is a complete cycle that takes place from 2. And this is the one that we cut it into 4 subintervals. Use the endpoints of the subintervals to find the 5 key points. Plot the 5 key points and connect them in a sinusoidal graph. And if b is not 0, apply a vertical shift of up or down. So what do we mean by this? Let's look at a very simple example to make some sense out of this. Again, in general, here's the amplitude, here's the period, here's the phase shift. So for this one to be done, number 1, you have to take out the 4. So we take out the 4. And now, what is the amplitude? Absolute value of -2, which is 2. What is the period? 2 pi divided by 4. 2 pi divided by 4. And that gives us pi over 2. Therefore, 0 to pi over 2 would be for a complete cycle if there was no phase shift. However, when we look at this, the phase shift is positive power 4. The phase shift is positive power 4. So this moves by positive power 4, meaning this moves this much to the right. So we're going to add this to this. And so the first one becomes power 4, this one and this one, they add up to 3 power 4. Therefore, just to give you an idea of what we mean by this, if we were just to pay attention to this, I have to write this. So you pinpoint power 4, you pinpoint 3 power 4. And if it was just the basic cosine, this is the part that you graph it looking like that. This is not a basic cosine because we have other things to consider, and that will be cut into 4 equal parts for the endpoints. All right, so we are going to cut this into 4 equal parts. In order to do that, this was the period. This has been shifted by this much. So we cut this into 4 equal parts, and it becomes pi over 8. Therefore, starting point is pi over 4. Then we're going to add pi over 8, and it gives us the next point. So this is the one that is going to be cut into 4 equal parts. This is the first part, add pi over 8. That number, add pi over 8. That number, pi over 8, all the way until we get to 3 pi over 4. So pi over 4 and pi over 8. So this is the starting point, is 3 pi over 8. Now this 3 pi over 8, we add pi over 8, gives us pi over 2. And we keep on going. Which means now, I want to make sure everybody understands what this means. We are looking for the following pairs, pi over 4, 3 pi over, and again, we are looking for those. Pi over 2, look at the green ones, 5 pi over 8, and 3 pi over 4. So those are what we are looking for. Just a simple example. Let's go with the first one. And we plug it in. We get -2 cosine of 4 times 0, because pi over 4 minus pi over 4 is 0, is -2 cosine 0. What is cosine 0? 1 times -2 is -2. I'm going to do one more, 3 pi over 8. If I put 3 pi over 8 minus pi over 4, I get pi over 8. I hope you realize this is pi over 8 now. So we have -2 cosine of 4 times pi over 8. Cosine of pi over 2, and that is 0. And I calculated this one for you. I calculated this one for you. I have a feeling you can calculate the rest of it on your own. So we did this, and we did this. you can continue with those. So those are the endpoints you are going to plug in. And this is what you get. We continue indefinitely. Notice this point at pi over 4. This one is at 3 pi over 4. And you continue indefinitely on both sides. So I want to make sure that we can read this. Let's look at another example to make some more sense out of this. Again, the very first thing we must do is to take the 2 out. So 3 sine 2 times x, and this becomes minus pi over 2. Why do we do that? First of all, the amplitude is 3. Secondly, the period is 2 pi divided by 2, which makes it pi. And then the phase shift is pi over 2. If you write it in this fashion, this format, then they work easily. You must take the multiplier 2 out. So first we take it out. The amplitude is 3, absolute value of 3 is 3. The period is 2 pi over 2, which makes it pi. As a result, we're going to go from 0 to pi. This means if there is no phase shift, but this tells us there is a phase shift of pi over 2, so we are going to add this to this, so we're going to move this. Originally, we're going to go from 0 to pi. Because of this phase shift, we are going to move by pi over 2, so we're going to go to pi over 2 to 3 pi over 2. So I hope everybody understands what this means. Again, this means the beginning to the end of one period. If there is no phase shift, as a result of the phase shift, this is moving to the right. Let's say it was plus, it would move to the left. That means you would subtract. So from pi over 2 to 3 pi over 2, and this is the part we are going to cut into 4 equal pieces. So in other words, if this is pi over 2 and this is 3 pi over 2, we're going to cut this into 4 equal parts. That's the idea, to find the endpoints. So to do that, the process is go back to the t and cut this in 4, so pi over 4. So that means this is your beginning, this is your end. We want 5 total points. There are 3 points in between. So add pi over 4 to this. So I'm going to add pi over 4 to this number, just so you see the first one. So this is the first one. Then if I add this number pi over 4, I get 3 pi over 4. This is my next point. Now that I have this one, I'm going to add the same thing, namely pi over 4. That gives me the next point, which is 4 pi over 4, or simply pi. Then I'm going to add pi over 4, and that gives me 5 pi over 4. If I add another pi over 4, let me, and I'm going to use a different color so you see what happens. I really don't have to because I need 3 points and I got it. But if I add another pi over 4, I get 6 pi over 4 or 3 pi over 2, which is this last number anyways. So we just want, we have the endpoints, the first one and the last one. We want 3 more in between. And that's how we get that. Look at those green ones. This is the first point. This is the last point. We keep adding pi over 4. This is the next one. This is the next one. This is the next one. So we have 1, 2, 3, 4, 5. So all you have to do, plug them in here and evaluate them. So I'm going to start with the first one. If I plug in pi over 2 here, plug in pi over 2. Pi over 2 minus pi over 2 becomes 0. 2 times 0 is 0. Sine of 0 is 0. Times 3 is still 0. So if I plug in pi over 2, clearly I get 0. Let me plug in 3 pi over 4 and show you. So if I plug in 3 pi over 4 here, I get 3 sine of what? 2 times, now, minus pi over 2 or minus 2 pi over 4, so it becomes pi over 4. This is pi over 4. 2 times that makes it pi over 2. Sine of pi over 2 is 1. That gives me 3. Okay. Now, after 3 pi over 4, plug in pi, everybody. If I plug in pi here, pi minus pi over 2 is pi over 2. 2 times pi over 2 is pi, sine of pi is 0. So this one gives me 0. I'm going to assume we can calculate the rest. So I calculated this one for you, this one for you, this one. You can figure out the rest. I hope everybody's okay with that. So plot those pairs. Go from pi over 2 to 3 pi over 2. Pi over 2 takes place at 0. 3 pi over 2 takes place at 0, and pi takes place at 0, okay? But what about in between 3 pi over 4 and 3? 5 pi over 4 and negative 3. This is it. One complete cycle. One complete cycle. And you continue indefinitely on both sides. It's very straightforward, everybody. Let's also look at this one. I want to make sure that everything is understood, even if it gets completely involved. And we have A omega, we have A omega phi b everything, something like that. So let's quickly go over that. First and foremost, the 4 should come out. The amplitude is 2, because the absolute value of that is that. The period t is 2 pi over 4, which makes it pi over 2. And so if there is no phase shift, we're going to go from 0 to pi over 2. So the period is pi over 2. So we're going to go from 0 to pi over 2. However, there is a phase shift of 3 pi over 4. So we're going to move this to the right by 3 pi over 4. So this becomes 0 plus 3 pi over 4. This becomes pi over 2 plus 3 pi over 4. When you add 3 pi over 4 to pi over 2, you can write this as 2 pi over 4, 2 pi and 3 pi, 5 pi over 4. Okay. So in other words, this is where we are going to have a complete cycle. Let's cut this into 4 equal parts. To do that, we got to cut the period by 4. Remember, 2 pi, we cut it into 4. The same thing. We cut this into 4. That becomes pi over 8. And so, again, the same thing. This piece we write. Here's the first point. Here's the last point. Now we keep adding pi over 8. So add pi over 8 to this one. So I'm going to add one of them, for example. This one, if I add pi over 8, you can say this is 6 pi over 8. So I get 7 pi over 8. So that's my next point. 7 pi over 8. I'm going to add pi over 8. I get 8 pi over 8, which is pi, and then 9 pi over 8. And so I have those points. So these are the points of interest, everybody. So all I have to do, plug in and evaluate. So clearly, if I plug in 3 pi 4, so if I replace this with 3 pi over 4, I get 0 and 2 cosine of 0 is 2, because cosine of 0 is 1, and subtract 1. So I get those pairs. I'm going to assume we can calculate the rest of them. I showed the calculation for 1. You can plug in and show the calculation for the rest of them. So pay attention to the points that we are going to plug in, and I'm going to clean up the mess, but I'm going to keep, so this one, this one, this one, this one, and this one. And so if we were to think about just plotting those pairs, we can easily come up with the answer. Also, you could do this without paying any attention to this, without the vertical shift. So in essence, you add 1 here, and so on and so forth. And now you shift down by 1, but you decide which one you want to do. You can do the best course of action, in my opinion. You don't need this. Just plot 5 pairs and you're done. If you are more comfortable with that, ignore the negative one and graph it and take the whole thing down. All right. All right, if we want to build a sinusoidal model in this format, and by the way, we can go with sine or cosine. Normally we go with sine, makes no difference. Amplitude is the largest data value minus smallest divided by 2. So that's how you get the A. B, the vertical shift is largest plus smallest divided by 2. Determining omega, we know T is 2 pi over omega. We know this. So omega is 2 pi over T. Determine the horizontal shift of the function by using the period of the data. Divide the period into 4 subintervals of equal length. Determine the x-coordinate for the max of the sine function and the x-coordinate for the maximum value of and the x-coordinate for the maximum value of the data. Use this information to determine the value of the phase shift. And what do we mean by that? We'll find out in a moment. So first and foremost, if this question is given where we want to write the equation of a sine function, we will look at this formula. And we say, okay, we need A. A is given. The absolute value of A is 3. T is 3 pi. Okay. So I need to calculate the omega, and omega is 2 pi over t. So I found the omega. Phi over omega I need here. Everything is given. I'm going to just plug in, and I don't see any b. So this a is 3, omega is 2/3 minus, so you're going to put minus 1/3, minus 1/3, which makes it plus 1/3. So I want to make sure you understand this is negative. So minus negative 1/3 will result in positive 1/3. And this is fine, and you're done. But sometimes they like to multiply the 2/3. They like to distribute it. If so, you can write it in this format. I don't think it makes any difference. I don't think any need for that, but it's up to you. Now we're going to look at how we come up with the sinusoidal function given data. So here's the last question. Draw a scatter plot and find a sinusoidal function for this. And this is the information that is given. I'm going to go over that. So first and foremost, to graph this, this represents a month of 1, 2, 3, 4. So we go with that. So it looks something like this. We graph it. And it's important to pay attention to the given January 1st, February 1st, so on and so forth. So we have the values. And so we know that the amplitude is max minus mean divided by 2. So where is the max? Here. Where is the mean? Here. And if you look at those values, here's the minimum value, here's the maximum value. That's where we get the numbers from, okay? So max minus mean divided by 2. So that's how we get to this number. So that's A. How do we get B, the vertical shift max plus mean divided by 2? So let's add those two. Let's add them instead of subtraction and divide by 2. So we have A, we have a B. The period is 2 pi, but in this case is 12 months. Because monthly temperature over a year, therefore we have 12 months. So we want omega, which is 2 pi over t, 2 pi over 12, pi over 6. Now, here's the next interesting thing that will help us find the phase shift. To understand the next one, I'm going to show you the general case of a sine x. Take a look at sine x. A basic sine x where t is 2 pi. This is where the maximum occurs. That means 1/4 times the period. That's where the maximum occurs. So for example, 1/4, if you multiply it by 2 pi, you get pi over 2. If you multiply it by 12, you get 3. Meaning, if there is no phase shift, there is no phase shift. So let me make sure we understand. If phase shift is 0, this is where the max occurs. Month of 3 should be where the maximum occurs if there is no phase shift. Since it doesn't happen, it happens in July, which is month of 7, then the difference is the phase shift. The phase shift is 4. 7 minus 3 is 4. So again, I want to make sure everybody understands. For a basic sine function, the maximum occurs here. Where is that? Pi over 2. You know that, right? Where is pi over 2? 1/4 of the period. So 1/4 of this number is 3 months. According to this, in month 3, it should happen. Because it doesn't happen, there must be a phase shift. How do we calculate the phase shift? The difference between the two. The month of July is the 7th month. Therefore, 7 minus 3 is when it happens. So x coordinate of the maximum value July is 7 instead of 3. So the phase shift must be 4. Here's the formula. A, we have it here. Omega times x minus 5 over omega plus b. We have it here. We write everything. This is omega. And this is 4. And this is the b. So A omega 5 over omega d phase shift and b. So all is taken care of.